Hello everyone, you're welcome back to my channel, Physics with Chaos. In this lesson, we are going to consider electric resistance. You're welcome back. Electric resistance. Resistance is a measure of the opposition to the flow of current in a circuit. It is a property of a material to prevent the smooth flow of current in a circuit. Resistance is measured in ohms with symbol omega. In a circuit, certain things prevent the smooth flow of current or even try to reduce the number of charge flowing per second. In this case, we have a resistor connected in a circuit and some particles in the resistor that prevents the flow of current from this end, the smooth flow of current actually from this end to this end. Okay? We have a figure here that shows the representation of what is happening in a circuit. We have the volts or the potential difference in a cell that gives the necessary push for the current to flow in a circuit. And then the ohm or the resistor that try to prevent the current from flowing smoothly. Notice that the current finds it difficult to flow in this section where the wire has a smaller diameter. Okay? Resistance in a circuit depends on the number of lamps present in a circuit. More lamp in series produces more electrical resistance in a circuit. Number two, the length of the wire. The longer the wire, the more the resistance to the flow of current. Number three, the thickness or the diameter of the wire. The more the diameter of the wire, the less the resistance as current flow easily in a wider space. In other words, the less the diameter of the wire, the more the resistance. Okay? And number four, the temperature of the wire. At higher temperature, it has been verified that less electron flow in a wire. Let's take these points one by one. Number one, when more components are added in a series circuit, the electrical resistance eventually increases. In this case, we have a cell supplying 0.9 amps current and then supplying it to a single lamp. Okay, when the lamp is doubled, the current reduced to 0.45 amps, and then when we have 3 lamps, the current dropped further to 0.3 amps. At the same time, the brightness of the lamps also dropped. These go a long way to show that the components offer a level of resistance to the flow of charge or flow of current in them. Okay? It means that the higher the more the number of components you have in a series circuit, the more the electrical resistance. Some components can provide more electrical resistance than others. If you have a buzzer, for instance, connected instead of a lamp, you tend to have less than 0.9 flowing. Okay? Using the same battery or cell, you tend to have less than this current, less than 0.9 flowing through it, showing that a buzzer have a higher resistance compared to a lamp. Okay? Number two, longer wires have more electrical resistance. It has been verified that resistance is directly proportional to the length of the wire. So the longer the wire, the longer the electrons have to travel, and the more likely they are to collide with ions. okay, in the conductor. These are ions they collide with and then be slowed down. Is that clear? Number 3, the more the diameter of the wire, the less the electrical resistance. This is shown here. With more diameter, the electrons flow smoothly. The wire gets heated up when the diameter of the wire is small and the resistance is high. This is because electrons force their way through the wire and hence creates too much friction that causes the wire to be heated up, like what we have here. Okay, so the wire is extremely heated up here because of friction of the electrons with the particles or the ions in the wire. Okay, at the same time, a heated wire don't permit as much electron to flow through them. Okay, resistor. A resistor is a device or is a component that is added in a circuit to prevent the flow of current in the circuit or to reduce the flow of current in a circuit. Okay, we have two types of resistors. We have the variable resistor, we have a fixed resistor. For a variable one, they come in different shapes and sizes with different values, like what we have here. We have 5, 10 and so on ohms. The fixed resistor are also color coded. Each color have a representation. Okay, the color coding tell us about the size of the resistor. Then the variable resistor or rheostat, like what we have here. This kind of resistor can be adjusted according to the specification required. If you need 5 ohm, if you need 10 ohms resistance, then you need to adjust it. Okay, when the adjuster of the variable resistor is adjusted to increase the length, like when you move it towards the side to increase the length of the wire in the coil, the resistance will increase. This is because the resistance is proportional to the length. So the more you increase the length of the wire in the coil, the more the electric resistance that it offers. How is resistance affected when current and voltage changes in a series circuit? So in a series circuit, we can alter the current, we can increase or decrease it when we alter the number of cells. Okay, in this case, when we increase the number of cells, the current flowing is also increased. In that case, we can say that current and voltage have this kind of relationship, direct proportion. Okay, they are directly proportional. So I here represent current and V here represent voltage, and this symbol here is a symbol for direct proportion. Okay, so current is directly proportional to voltage. When you increase voltage by increasing the number of cells, you're also going to increase the current. On the other hand, when you increase the number of components, you will decrease the current flowing in a circuit. Remember that each component have a level of resistance to the flow of charge, as we discussed earlier. Okay, so with more components, we'll have more electrical resistance, and this will eventually reduce the current flowing. This kind of relationship is called an inverse proportion, written this way. Okay, so in this case, we can say I is inversely proportional to R. This is I current, R represents the resistance. Combining the two relationships, we can have I equals to V over R. This is known as the Ohm's law, and it states that current in a metallic conductor is directly proportional to the voltage at constant temperature or resistance. Okay? How is resistance affected when current and voltage changes? That is in the parallel circuit. I want to check out if what happened in the previous slide is the same thing that will happen in this. Okay, so in a parallel circuit, we can increase the current by increasing the number of voltage that is certain. Okay, so it follows this relationship. The current is proportional to voltage in a direct manner. But when you increase the components in parallel circuit, you will think that the resistance, the current flowing will decrease, but no, it will rather increase. Like here we have 0.4 amps flowing with a single lamp, but with two lamps in parallel we have 0.8 amps flowing, so the current is increased. Okay, this go a long way to show that with more components in parallel connection, the resistance eventually drops and current increased. Okay, so it follows this pattern, this relationship. The current is inversely proportional to resistance. Okay, when we put these two relationships back again, we get what we got before. I equals to V over R, which is known as the Ohm's law. Okay, so this is applicable in both cases. Ohm's law is applicable in the first case and in the second case. Okay, if I represent the current in amp and R represent the resistance in ohms and V represent the voltage in V, then I will be equals to V over R, or V equals to I over I times R. In other words, we can also have R to be equal to V over I, okay, from this triangle formula. Okay, so this gives us a good relation, a good formula that we can apply to calculate the total resistance in a circuit. Question: a filament bulb has a current of 0.2 amps running through it with a potential difference of 5 volts across it. What is the resistance of the filament bulb? Applying this relation, V equals to IR, we can make R the subject, R equals to V over I. That gives us 25 ohms when we plug in these values in the relation, the equation. Okay, calculate the voltage across a resistance of 40 ohms when a current of 5 ampere is flowing. Using V equals to I times R and plug in those values, 5 for current, 40 for resistance, that will give us 200 volts. Okay, calculate the current flowing through a wire of resistance of 8 ohms when a current of 12 volts is connected to the wire. Using I equals to V over R, or current equals to voltage over resistance, we are going to get 1.5 amps when we plug in these values in the formula. Okay, guys, for more videos like this, please leave a thumb up and click on the subscribe button below to subscribe to this channel. Have a nice day.